This is problem number 6 from section 4.5. In this problem they say find all zeros of f of x for part A. So part A, I'm going to set this equal to 0. So x cubed minus 4x squared plus 9x minus 36 equals 0. Now there's 4 terms here. So usually when there's 4 terms, I like to try to factor by grouping. Now the numbers seem to be pretty small, so I feel like that I'll be successful there. So I'm going to group this together and this together. When I take something out of this, I'm taking x squared out, I end up with x squared. And then what's left is x minus 4 from the first 2 terms. And I'm going to factor a 9 out of this one. So I'm going to have plus 9, and that's x minus 4, which is left there. Notice that I have now 2 terms. This term is combined with multiplication. This term is combined with multiplication. And in these 2 terms, I have x minus 4 in both. So I can factor out x minus 4, and what's left is x squared plus 9. So I end up with x minus 4 when I factor it out of this term and this term. And what's left over would be x squared plus 9 equals 0. Now I'm at a spot where I can use the zero product property. So I can say x minus 4 equals 0, or x squared plus 9 equals 0. Solve this side, I get x equal 4. Or solve this side, I get x squared equals negative 9. When I subtract it, I square root each side, so I get the root of x squared equals the root of negative 9. This will give you x, and this gives you, well, the negative is going to give you an I, and root of 9 is 3, so that's going to be plus and minus 3i. So our zeros are x equal 4, or x equal 3i, or x equal negative 3i. Those are the zeros for this function. So now I need to do part B, and part B says write the complete factored form of f of x. I can create factors using x minus k. So I have a 4 here, and remember x minus k, k is a 0. Well, I have zeros right here. So I have x minus 4 times x minus 3i times, I'm going to have x minus negative 3i, which is really just x plus 3i. And we know that we have to have the conjugate with these imaginary numbers because of the conjugate zeros theorem. So this is the complete factored form for part B.